All right, now we're going to look at 1747. So it says determine the maximum angle. So we want to find theta of an incline that will allow an 8-kilogram mass above to remain stationary. The coefficient of static and kinetic friction are, so this is equal to 0.2 and mu sub k is 0.1. Now remember, static is always greater than kinetic. Okay. Now, there's people that just memorize the answer to this, but we're not going to memorize it. We're going to actually understand it. Okay, because memorization doesn't help you. All right, so the first thing I'm going to do is, and this is 8 kilograms, and we want to find mu. The first thing I have to do is I have to establish which direction the object would move if it was going to move, and then that's going to help me establish my sign convention. So if this was to move, the way it's going to move is it's going to move down the incline. So I'm going to actually draw this on my picture because that is essential for working this problem. Now I'm going to draw my sign convention. So if it's moving this way, I'm going to make moving positive, x and y, and this is the direction in which it's moving. The next step is I'm going to draw my free body diagram. So here's my incline. Here's my box. So first of all, I know the force of weight always acts down. I know the normal force is perpendicular to the surfaces in contact. Now, if the boxes have a tendency to go down the incline, this is why you have to establish your sign convention. That means the frictional force is going to go opposite the direction of motion. So now I have all the forces acting on it. Okay, so this is theta. Now I'm going to look at this, and when I sum my forces, I want all my forces to either go in the direction of motion or perpendicular than that. So this is parallel to the surfaces in contact and then perpendicular to the surfaces in contact. So the first thing I'm going to say to myself is there any force or forces, are there any forces that are not perpendicular and parallel? So the ones that are not is going to be the weight. So what I'm going to do is I'm going to redraw it again. And here's my box. And before I redraw it, I'm going to say which force or forces are not going, and that's going to be the force of weight. So I'll do it to the side, because when I do it to the side, I don't make a mistake. This is F of G, which I know F of G is mg. And again, this is where I start. So look at the picture here. First, I'm going to go perpendicular, like that. From the head of this vector, I'm going to go to the tail of the other parallel. And that's my right triangle, and there's theta. So there are similar triangles. So I'm going to just draw it here because I like to do it neatly. So here are my components, and do you see the directions of the arrows? These are important. So this is what I'm going to call FGY, and this is going to be FGX. So FGX, this is opposite the angle. So FGX is going to be F of G sine of theta, so FGX is mg sine of theta. FGY is adjacent, so it's FG cosine theta. That's why you should never memorize like sine or cosine. As far as like if I'm looking for my x or y, look at your picture. So FGY is equal to mg cosine theta. Remember, I'm solving for theta, so I'm just going to leave it like that. Now, I'm going to now draw my free body diagram. So again, the object is moving this way. This is my sign convention, which I'll just draw positive like that. So f of f hasn't changed. F of n hasn't changed. And instead of f of g, I'm going to replace that with fgy and fgx. And remember, these arrows of directions are important. Okay? You don't just like randomly draw them on there. All right, so what should I do? Well, in this case, I want to solve for theta, and I'm not even sure where that's going to end up, okay, my theta. So because I'm not sure what to do, let me just do the 3 things that I'm going to do on every problem in the order, and then maybe it'll tell me. I know the 3 things I'm going to do is I'm going to sum forces horizontally, I'm going to sum forces vertically, and I'm going to use the mu equation. Okay, that's what I do usually for every problem. Some you don't have to do all 3, but I'm not sure what I'm doing on this, so I'll just go with that. So number 1, I'm going to sum forces. Now I'm calling to the left positive down the incline parallel. So summation of f of x is equal to ma. So now I'm going to look at my free body diagram. F g x is positive minus f of f is equal to ma. Now, is this box accelerating down the incline? No. They're saying what's the angle to keep it from moving? So the key to this is, in the beginning, it said stationary. So stationary means that it's at rest. So this is 0. Now, I'm going to look at what I did, and I know that f g x is mg sine of theta minus f of f is equal to 0. Now, I don't know f of f. So f of f is vertical. So let me just go ahead and do that. So step number 2 is, I'll say let me sum forces vertically. Summation of f of y is equal to ma. Is this block accelerating in the y direction? No, it's not even moving in that direction. So again, this is equal to 0. So now when I look at my free body diagram here, f of f is, oh, I mislabeled this and no one said anything. This is f of n, obviously the normal force. So when I look at this, I have Fn minus Fgy is equal to 0. So Fn is equal to Fgy, which is equal to mg cosine theta. What's the third thing that I do? The third thing that I do is I say mu is equal to f of f over f of n. So f of f is equal to mu times f of n. So that's equal to mu mg cosine theta. That's what f of f is. So now, let me go back to this. Now I'm going to take this, and I'll go back here, and basically what I'm going to have is mg sine of theta is equal to f of f. But now I found f of f. So mg sine of theta is equal to mu mg cosine theta. Okay. What am I solving for? I'm solving for theta. So let me throw all the thetas on one side. So I'm going to leave the sine of theta where it is. I'll divide by cosine theta. Then the mu mg is over here, and then I'm going to divide by mg. So now what you're going to see is you're going to see these cancels, this cancels. Sine over cosine is tangent. So tangent theta is equal to mu. And that's it. So sometimes teachers just tell you to memorize this, but this is how you actually understand it. All right. And then in this particular problem, so tan of theta is equal to 0.2. So in my calculator, I put 0.2 and then second tan. So theta comes out to be 11.3 degrees. Now, why did I use the 0.2? Because in this case, we're using the stationary because it's not moving. So it's not moving, so we're using the static one. That's why we're not using the kinetic. Whoops. And that's it.